similar questions.
Is that a table again?
Yes. What I'd like you to do is, I know there's a little bit of copying, right, simple interest over 2 years, then we're going to look at compound interest over 2 years, compounding annually, which is essentially the table you did last night. However, here, we're going to look at simple interest over 2 years, but instead of compounding annually, it's going to compound semi-annually, or every half year. So instead of receiving the interest payment at the end of each year, this time we're going to receive it at the end of each 6 months.
Did we just do that in a notebook?
Yeah, notebooks. And we'll look at the difference between simple interest over 2 years, compounding annually over 2 years, and compounding semi-annually over 2 years. And we shouldn't be able to notice a pattern through that. Alright. So let's say we deposit $10,000 for 2 years at 6%. Now, if we were looking at only simple interest, how do we calculate how much interest we earn?
10,000 times 2 times 0.06.
Good one. So our interest equation is interest equals P, the principal, how much we put in the start, times the interest rate, little I it should be, times time. I. Thank you, times time. And our rate or interest is in decimals, so for us this would be 10,000 times 0.06 times 2. Yeah. So we have an interest of $1,200 giving us a total. What would be the total that we get back at the end?
11,000.
Yeah. Is the 10,000 plus the 12,000, 1,200. That's not right. Alright. Now, this table is a miniature of what you did for homework last night, but how much we start off with for principal here?
10,000.
Then our interest would be 10,000 times 1 for the years times 0.06, and that would get us an interest payment of $600, giving us a total balance at the end of the first year of $10,600. Right? So we put $10,000 in the bank account. Over the first year, it earned 6%, which means it earns $600. And at the end of the first year, you had what you put in at the start plus the interest, so $10,600. Now, at the start of the next year, you have $10,600, and you want to work out how much interest you earn on that. So again, it's only there for 1 year, and for 0.06 earns you an interest of $636, giving you a total of 1,236.
1136.
Thank you. 1,236. You are. It's good. All right. Now, we did look at this yesterday, so we shouldn't be surprised. We shouldn't.
That's not going to stop. It's for the doors.
Excellent. So, we looked at this yesterday, so we shouldn't be surprised to see that when we compound over 2 years, we earn a higher rate of interest. We earn more interest than over simple interest for that 2 year period. Now, when we look at same 2 year period but compounding half yearly, this column, we no longer really talk about years. We talk about compounding periods. Okay? So each period is a length of time required for it to compound. So if it's compounded half yearly, there are 2 periods in a year. If it's compounded monthly, there'll be 12. Quarterly, there'll be 4. Get the hang of it? Here, to make our table nice and simple, we're only doing half yearly. So in 2 years, each year has 2 periods because it's half yearly. So in total, we have 4. Now at the start, again, we start off with $10,000. That's how much we put in. How do we calculate the interest earned during the first period?
It's talking about one.
Yeah. So up the top here, we've done the principal times the amount of time, the time just being that 1 year. However, here, the time is no longer the 1 year, the time is the length of time within the period. So it is 10,000 times 0.5 times 0.06. Now, do you think you can follow through this pattern for the rest of that table?
Yep.
Alright, can I ask you to do that to save me yelling over the drill? So for each period, it's only a half a year, so 0.5. Alright. So most of you have worked through and you've discovered that the final total is 11,255. So when we compare our three totals, the top one in blue being the simple interest, the next one in yellow being the compounding each year, and then the green one at the bottom being compounding twice a year, what we see is that there is a slight increase in the amount of interest earned each time. So just simple interest over 2 years, we get 11,200. Then compounding yearly, we get an extra $36. And then compounding twice yearly, we get an extra $20 or so on top of that. So the general pattern, yeah, okay, about $20 on top of that. Yes, Nikki's on the ball today. The general pattern is that the more often you compound, the more interest you will earn, or the more interest you will owe. So if you have a credit card debt and don't pay off the credit card and it's compounding regularly, it means your credit card debt will grow more quickly. Now, the vast majority of loans you'll come across when looking at car loans or house loans compound monthly. Almost everything is done monthly. However, for us to do this table method monthly would require 12 lines for each year. Yeah, 12 rows for each year, which is no fun at all. So there is a slightly quicker method. Now, this quicker method involves a formula.
I thought you said it was on our calculator.
Yep, that's the quickest method. I have to teach you 3, I'm afraid. Now, compound interest formula has some interesting parts to it. The formula itself is FV equals PV.
Is that the future value present value?
Yes, good.
I learned that last year.
You'll have seen it last year.
Like last time, when did you see in this class?
No,
No.
not sure. Yeah. I think we use a formula like that, but I don't think.
Now this formula looks okay when you first see it, but there's some tricky parts to it. Future values is enough. FV stands for future value. Which is the value at the end of the time period. So the amount of money at the end, or final amount. Note this is going to be equal to the principal plus the interest. So before, you see this number highlighted in green, that is the final amount. It is the 10,000 we had at the start plus the interest earned over the period. This formula, when it gives us FV, the future value, gives us the principal plus the interest already. Okay? So it's not like when we're using simple interest and we calculate the amount of interest earned and then have to add it on to the principal to get how much we have at the end. This gives us how much we have at the end straight away. PV is present value. It's the amount you have at the start of the loan. Now, I is the interest.
Is N the number of years?
Not quite. This is where it gets more complicated. I is the interest per period. Alright? So if it was 6% annually, and we write annually quite often as P dot A dot, if it was compounded monthly, so I'm going to put an example in, 6% per annum compounded monthly, the I would equal the amount of interest in each month. So if it's 6% over the whole year, that interest is effectively split between the months. So the I would equal 6 divided by 12.
So it ends the period.
Yes, you divide it into the number of periods. So I is the interest rate divided by the number of periods. And it's written as a decimal. Alright? So 6 divided by 12 will get a decimal, I know. We'll get you 0.5. But then that has to be divided by 100 also. Some people prefer to divide the interest into a decimal first. So for example, you divide 6 into 0.06, because that's 6%, and then divide it by 12. Which is that. If it was 6% compounded half yearly, then the interest would be 0.03, because it would be 6% for the whole year, but each half is 3% effectively. And I know this is confusing because it's different to simple interest. And that's why we use different letters. So simple interest is we use R for rate, but I here is the interest per period. And this is a much quicker way than the table, but is slightly more complicated than the table, I think. But once you understand the formula, it's easy enough to use. And today we'll move on after some practice with the formula to using the calculator, which is even nicer. Alright, N is, yes, time related, but it's the number of compounding periods. So it's not just the 2 years. If it was 2 years compounded monthly, then there are 12 periods in each year, so it would be 24.
So is that in months?
No, it's a number of compounding periods. So for example, if you say you took out a loan for 5 years, compounding quarterly, each year there will be 4 periods because it's compounding quarterly.
So then it would be 20.
Yeah, it will be 20, so N will be 20. But the units aren't months, the units are just periods. Because a quarter of a year isn't a month, it's 3 months. You'll get easier with
Down
that.
as like an example.
Yep. So 5-year loan compounded quarterly will be 5 years times 4 is the 20. N would equal 20. Alright, I'm going to write this equation on the whiteboard and then we're going to go up and check our table work using the equation. Future value equals present value multiplied by 1 plus I to the n. So, if we look at our first table and we want to do it without using the table, then we have our future value equals present value times 1 plus I, you know what I mean, that's a plus, to the n. Now our future value is what we're trying to find, so we leave it as that, but what's our present value?
10,000.
Yeah, that's what we start off with. What is our interest rate?
0.06.
Yeah, 0.06, and it doesn't change because that's the interest rate in one period, which is a year. And n is the number of compounding periods, it's 2. So now, we put that in the equation, we get future value equals 10,000 multiplied by 1 plus 0.06 to the power of 2.
It's the right answer.
Excellent. That's exactly what we'd expect from above. Now the brackets are important. You do need to put that 1 plus I in brackets, otherwise that squared will only act on the 0.06. Alright. Similar thing with our table here. Once again, we start with our same equation. This is the working I'd like to see in any test you do. Future value equals present value times 1 plus I to the n. Now, future value we don't know. Present value again is 10,000. Those are the easy ones. What is interest? It's the interest in each compounding period. Yeah, so it would be the interest for the year dividing by the number of compounding periods in the year. And finally, what is n? If there are, 4, because we have 2 years and in each year it compounds twice. 4. And you'll notice on the table up above we had 4 lines or 4 periods. Alright? Then we put our numbers into the equation. FV equals 10,000 times 1 plus 0.03 to the power of 4. Which is the same as we got above. However, it meant we didn't have to go through all those 4 lines of calculations that you'll have in your books. Yeah? So, formula's quicker, providing we put the right numbers in. What I would like you to do now is look at... So the question you started for homework, you did question 1 in tables. I'd like you to do questions 2, 3, 4 using the formula, and then turn over to the next page and look at 1, 2 and 3 using the formula, but careful, the next page, the compounding periods aren't the whole year. They work in quarterly or half yearly. All right. And I'll come around and help you as you go.